Alright, Mr. P helps with Algebra 2, Unit 1, Topic 3, SLT17. This time we're going to be exploring the effects of compounding always, which is continuously. So we're going to be doing E, which is Euler's rule. So need to deposit $800 into a savings account with an annual interest of 6%. So we're starting with a simple interest question. So we start with $800, we're multiplying by 1 plus the rate, which is 6%, so that's 1.06. to the power of x, which in this case is 10, so 10 years. So now it's just a matter of putting that in my calculator, 1.06 to the power of 10, and then multiply that by the $800 initial principal, which is how much money you had to begin with, and it looks like after 10 years, you're going to have a whopping $1,432.68, which sounds great, because it looks like you have just pretty much doubled your money, but it took 10 years to do that. And 6%, yeah, banks don't usually give you 6% nowadays. So that would actually be a great thing if they did. Alright, that's the same question that we just did a second ago. So this is about exploring what happens when you are doing compounding continuously. So if you are compounding annually, which basically just means regular exponential growth. So that means you're compounding it once at the end of the year, and you're really not making any interest on any of your interest at all. So that's 1 per 1. If you are compounding every 6 months, that means you're compounding it twice a year. So you're doing it every 3 months, that'd be 4 times a year. 1 month would be 12 times a year. Every week would be 52 times a year. And 1 day would be 365 days. Now, what we're going to be exploring here is basically finding out that the more times you compound it, the more interest you're making on your interest. So if you compound it twice, which means after 6 months and then 6 months again at the very end, what you're doing is you're not just making the interest over the year. So if you make like 100% growth over the course of 1 year, so let's say you have $2 in the account, you make 100% growth, at the end of the year you'd have $4. At the end of the next year you'd have $8. But if you compounded it in between, not only would you be making the $2 that you make for the entire year, but you'd also be making interest on the interest that you got the first half of the year. So you would make, $1 the first half of the year and then another $1 the second half of the year. That's the reason why you're increasing by $2. But after you've made that $1 after the first half of the year, you're also making interest on that dollar, which means you're actually making interest on $3 instead of just $2 for the second half of the year. So that's the reason why the more times you compound it, the more money you end up making. So when you're doing this, so it'll be the exact same each time, but it's going to be 1 plus the rate, which is 0.06. That's not going to change, but it's going to be divided by number of compounding periods. So in this case, so that would be, let's say, this looks like monthly, so that'd be 12 times. Number of compounding periods, which would be, okay, so why is that one? So, oh, that's how many times. Okay, so this is all monthly. I'm sorry. So this is, after 2 months, after 3 months, after 4 months. Okay, so I thought we were comparing the amount of times that it was compounding, which it clearly wasn't. Okay, so just take my word for it. The more times you compound it, which means you're making more interest on your interest. Now, there is a total amount that you can possibly make. So if you make 100% growth over the course of a year, if you compound it an infinite amount of times, so if you only compound it once, obviously you're just doubling your money. But if you do it twice, so if you compound it semi-annually, you're going to make interest on that interest, so you're going to make an extra, it could be half of, 100% of, so it'd be another extra 50 cents, so forth, per $2, so doubling your growth. So, but there is a total amount that your $2 could never just turn into $1 million. It never could do that. It would stop because E, which represents 2.718, approximately it's an irrational number. It goes on and on forever. It's kind of like pi. That represents the highest amount that you could possibly make on compounding 100% interest over the course of 1 year. Okay, so that's what E stands for. E is continuous compounding, and that's the absolute most you would possibly make, because the more you compound it, the more you make. So if you compound it every day, you make more if you compound it every hour, if you compound it every minute, if you compound it every second, every half a second, every split second, every tenth of a second, 100th of a second. Okay, if you keep going, okay, we're being kind of ridiculous here, but sooner or later, you're going to pretty much be at 2.718, which is the absolute most it can possibly be. Rate of function represents the amount of an account after 2 years of $800 put into 6% compounded monthly. Okay, so it's a lot like the question we did with the warm-up. So that's $800 times 1 plus the rate, which is 0.06. But we're not making that per month. That was per year. So we have to divide that by 12 months. So that's how much you would make that's the amount of interest you would make per month. But then if you're going to do that, you got to split it, then you're going to make that 12 times over. Okay? Remember, it's just like divide by 12, multiply by 12, those cancel each other out. That's basically the exact same thing. So that's to the t power, which is how many times, or x power, however many times you're going to be keeping it in there. So that's the amount of years. All right, so rate of function represents, okay, so basically we came up with the equation. So that's basically what we were just doing a second ago. All right, so now let's solve some simple and compound interest questions. Semi-annually, so that's $7,300 times 7% growth, so that's 1 plus 0.07, compounded semi-annually, which means twice a year, to the nt power, so that's 2 times 3. So you would do 0.07, so if you're putting this in your calculator, so that's 0.07 divided by 2, gives you 0.035, add that to the 1. So that's how much that's the rate that you're going if you did it semi-annually. And then you got to raise that number to the 2 times 3, which is 6th power. And then multiply that number by your amount that you had initially. And that's going to give you $8,973.56. Now, if you can see that, that's what I put in my calculator. There it is. So you can pause the video if you want to see that again. All right, so let's do another one of these. So that's $1,030. That's compounded semi-annually again. Okay, so that's 1 plus 0.04 divided by 2 because it's semi-annually to the 2 times 2 power. All right, so that's 0.04 divided by 2 plus the 1, because that's in parentheses. You have to do that next, to the 4th power, because 2 times 2 is 4. And then multiply that by 1,030. And there's my answer, $1,114.91, rounded. Okay, so there's enough of those semi-annually. So that was enough of those. So let's go to one that's quarterly. So this is 21,000 times 1 plus, okay, the rate is 13.6%. If I move the decimal twice, that's 0.136 divided by 4 because it's compounded quarterly. That means 4 times a year. So the 4 times 4. So that's quarterly times 4 years. All right, so that's 0.136 divided by 4 plus the 1 to the power of 16. And then multiply that by 21,000, and looks like you're going to have $35,854.85. Once again, I know that sounds like that's a whole lot of money, especially in only 4 years, but that's kind of a ridiculous amount. So we're not talking about how much interest you're making at the bank, but we could be talking about maybe something, value of something is increasing by that percent, and maybe that would make more sense. Okay, so these are all like real life examples. So this could be a real life example. It could be maybe a stock, which was worth $21,000. And if it increased 13.6%, then that's how much it could have been if it had been compounded. I know that doesn't really make sense in the context of the question I just gave. All right, get into the homework. Your 3-year investment of $20,000, so $20,000, received 5.2% interest, so that's 1 plus 0.052. Notice I moved the decimal twice to the left. Compounded semi-annually, which means 2, to the 2 times 3 because it's been 3 years. Okay, so 0.052 divided by 2 plus the 1 to the 6th power. Then multiply that rate by 20,000. 1, 2, 3. Perfect. And it looks like it's going to be $23,329 and about 97 cents. All right, so I'm going to erase that one. You borrowed $59,000. And for 2 years at 11%, which was compounded annually, what is the total that you will have to pay back? Okay, so that's 1 plus the rate, which is 0.11, divided by compounded annually. Okay, so just 1, so the 1 times 2. Now, I didn't have to use the compound growth equation this time. Since it's compounded annually, that's really not really compounded at all. That's just once per year. So I could have just used the regular growth, just 1 plus the rate to the power of x. Because dividing by 1 and multiplying this by 1 doesn't change anything. So that's still 1.11 to the power of how many years? That was 2 years. And then multiply that by 59,000. And that's going to be 72,693.90. Great. Your allowance of $190 got 11% compounded monthly. So that's 0.11 compounded monthly, which is 12. And that's to the 12 times 1.6 repeated. Okay, what's it worth after 1 2/3 years? All right, so 1 2/3, that's 1.6 of a year. So now there's 12 months in a year, so 2/3 of a year would be, let's see, if you break that up into thirds, it'd be 8 months out of the 12 years. So it's really 8 months. Now, I'm not going to change that to 8 months. I'm just trying to think about what the question actually means in the context. So 0.11 divided by the 12 months plus the 1 of the growth and to the, I'm going to put this in parentheses, 12 times 1.6, and I'll put that a couple times because it's repeated. All right, and that's going to give me about 1.200124. Now, the way you round it might have been a little bit different than me, but you should be pretty much the exact same. So that's going to be about, when you multiply it by 190, $228 and about 2 cents. All right, thanks again for watching. If I helped you learn something about compound interest and simple interest and the difference between the two, and we also talked about Euler's rule, then give it a like. All right, thanks again for watching.